So what exactly is the factor theorem? The factor theorem says that for p of x, c is a solution if and only if x minus c is a factor. So for any polynomial f, the following are logically equivalent statements. X minus c is a factor. P at c must equal 0. That's why c is called a 0. C is an x-intercept. That's why we look on the graph to find the zeros. We say that c is a 0 or a solution. They are the same thing. X-intercept, zeros, and solutions are all the same thing. And the remainder, when p of x is divided by x minus c, must be 0, or else it wouldn't be a factor. If it had a remainder, it's not a factor. So let's look at example 1. They tell us that one solution to this equation is x equals 5. Find the other solutions. Well, if x equals 5 is a solution, or 0, then x minus 5 must be a factor. So how do we find the other ones? Well, we can take x minus 5, and since it's a factor, we can divide it into 6x cubed minus 25x squared minus 31x plus 30. And we can see what we get. So the first thing is, if x equals 5 is the solution of 0, then x minus 5 must be a factor. Our second step is then to divide. This is a process we're going to follow over and over again. So I have no missing terms where I have to put in a placeholder, so I focus on the first. 6x cubed divided by x is 6x squared. I'm going to multiply that out. 6x cubed minus 30x squared. Now I'm going to change my color so that my signs, I change color to change my signs. Since I'm subtracting, I'm going to go ahead and change those signs. Now I can simply add, and I get 5x squared minus 31x. I carry down, focus on the first. 5x squared divided by x is 5x. So I've got 5x squared minus 25x. Subtracting, so I change my signs so that I can simply add up. And I get negative 6x plus 30. Focus on the first. Negative 6x divided by x is negative 6. And I end up with negative 6x plus 30, which is what should happen. Because it's a factor, you should always get a remainder of 0. If you don't, you know you made a mistake dividing. That's the nice thing about these, is that when you divide and get a remainder of 0, you want to make sure that you get a remainder of 0. If you don't, you made a mistake. Now my third step is to factor my quotient. And that will allow me to find the other solutions. So I have 6x squared plus 5x minus 6. I'm going to use slide and divide, and I get x squared plus 5x minus 36. I factor that, Using my diamond, I want a product of negative 36 and a sum of 5. My factors of 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9. As soon as I see 4 and 9, I'm like, oh, I could get 5 from that. I could have 9 minus 4. So x plus 9, x minus 4. But remember that this is not what I want. I want actually this. So now I've got to unslide and divide by 6 now. Reduce x plus 3 halves, x minus 2/3. Bring my denominators over, and I get 2x plus 3 and 3x minus 2. So now that I have these factors, find remaining solutions or zeros. Well, so if I set each of these equal to 0, back at this step, it makes the 0 very noticeable, because when you set each of these equal to 0, you're going to end up subtracting 3 and dividing by 2. And I'll just show that. I don't want to confuse things. 2x plus 3 equals 0, and 3x minus 2 equals 0. I'm setting each factor equal to 0. Subtract 3, divide by 2, negative 3 halves, add 2, divide by 3, and there are my other two solutions. So I have x equals 5, x equals negative 3 halves, x equals 2/3. These are all 3 of my solutions. I first had a factor, so I divided, factored my quotient, found my zeros. These are the 4 steps that you will follow. All right, the next example, example 2, says find an equation for a polynomial with the following zeros. Well, when you know the zeros, you know the factors. When you know zeros, you know factors. So I would have x plus 1, x minus 4/5, x plus 8/3. Can't leave these fractions though. That's going to slide over and that's going to slide over. So I actually have x plus 1, 5x minus 4, and 3x plus 8. But it says find an equation for the polynomial. So now what I need to do is I need to multiply this out. So I'm going to, I guess, start by multiplying these two, and then I'll have to multiply by that. So let's start by foiling the first two. And I get 5x squared. Outer term, negative 4. Inner term, positive 5. Negative 4 and positive 5 is positive x minus 4 for the last term. So I need to take that now and multiply it by 3x plus 8. You can do it in a table, or you can simply distribute. I'm going to distribute that 3x to each of these, and I get, I'll put my answer over here. When I distribute the 3x to each one of these, I get 15x cubed plus 3x squared minus 12x. Now I'm going to distribute the 8 to each of these, and I get 40x squared plus 8x minus 32. My final answer is 15x cubed plus 43x squared minus 4x minus 32. All right, example 3. If you are given the equation and it's already factored, identify the zeros. So you're going to set each factor equal to 0 and solve to find the zeros. So we keep going back and forth. Here I knew the zeros, so I wrote the factors. Here I know the factors, so I'm going to write the zeros. X equals 0, x minus 3 equals 0, 4x minus 1 equals 0, and x plus 6 equals 0. This one's already solved. Add 3. X equals 3. Add 1. Divide by 4. Subtract 6. So from my factors, I found my zeros. Again, from my zeros, I found my factors and could multiply to get my polynomial. And up here, I did a little bit of everything. So on the lesson master, you're going to be doing exactly what we've done here. So let's look at the lesson master next. Well, let me get that paper real fast. All right, so for the lesson master, you can use your notes that we took, and all the notes that you're going to look at, use page 2 of your Factor Theorem notes. Okay, that was the page we just finished. Number 1, if you get stuck, use example 2 as a guide. This is the same as example 2 in the notes. If you get stuck on number 2, I would say see a definition of factor theorem. Same with example 4, see definition of factor theorem. All right, and then let's see, number 3. If you get stuck on number 3, this one you're going to see how we did all of the examples on the first page of notes. That's how you're going to do example 3. Okay. And then, yep. And let's see, then when you get down to number 6, I'm sorry, next one you have to do, oh yeah, number 5, sorry, I was skipping to number 6. Number 5, what you want to do, it says actually one factor, I changed it on yours, find the other, solutions, find actually all the solutions, find all solutions. This is where you want to use example 1. Use example 1. In your page 2 notes on factor theorem. So follow along the same way we did example 1 in your page 2 notes on the factor theorem. That's how you're going to want to do that. And for number 6, what you're going to do is you're going to, for part B at least, I think part A will be obvious for you. For part B, you're going to 1